Welcome to this lesson on optimizing network service performance using zero-copy I/O. In today's highly connected world, network services like web servers, proxy servers, and content delivery networks are fundamental. Their efficiency directly impacts user experience and operational costs. A major bottleneck in these services often lies in how they handle input-output operations, particularly when moving data between storage, memory, and network sockets. Traditional I/O methods involve multiple data copies and context switches, consuming valuable CPU cycles and memory bandwidth. Over the next few minutes, we'll explore these inefficiencies and then dive into advanced techniques like sendfile and splice that revolutionize data transfer by virtually eliminating these bottlenecks, leading to significant performance gains and a smoother experience for the end user. Understanding these concepts is crucial for anyone building high-performance network applications.
Let's first understand what happens in a typical data transfer operation using the traditional read and write system calls. Imagine a web server serving a static file. The process begins with an application requesting data from the kernel using read. The kernel then reads the data from disk into its own kernel buffer. Next, the kernel copies that data from its buffer into the application's user space buffer. Once the data is in the application's memory, the application calls write to send it over the network. The kernel then copies the data again from the application's user space buffer back into a kernel socket buffer. Finally, the kernel sends the data from the socket buffer to the network interface. This entire sequence involves 4 data copies and at least 2 contact switches between user and kernel space, which is far from optimal.